Today I'm going to talk about endogeneity in empirical corporate finance. Here is how my presentation is organized. Firstly, I will talk about endogeneity and describe its concept, and I will review the sources of endogeneity and their implication for inference. I will finish with econometric techniques aimed at addressing endogeneity problems. First of all, let's recall the regression framework. We can see here the single equation in our model, where y is the dependent variable, the x is at the explanatory variables, u the unobservable random errors, and the betas are the parameters to be estimated. Good estimators should be unbiased, efficient, and consistent. There are 4 key assumptions needed for OLS to produce consistent estimates of the parameters. Firstly, the errors have zero mean. Secondly, entirely errors terms are almost stochastic and have zero autocorrelation. The fourth assumption is that there is no relationship between the error term and each explanatory variable. This is called the exogeneity condition. Violation of assumption 4 is the primary cause of inference problems. We can define endogeneity as a correlation between the explanatory variables and the error term in a regression. It leads to inconsistent parameters estimates that make reliable inference virtually impossible. It is important to mention that there is no way to empirically test whether a variable is correlated with the regression error term, because the error term is unobservable. Moreover, it is also very important to make clear which variables are endogenous and why. Let's move on to the sources and consequences of endogeneity. There are 3 causes for endogeneity. The first one are omitted variables. It means that some variables should be included in the vector of explanatory variables, but for some reason they are not. The inability to observe these determinants means that instead of appearing among the explanatory variables, these omitted variables appear in the error term, u. If these omitted variables are uncorrelated with the included explanatory variables, then there is no problem for inference. The estimated coefficients are consistent and, under the strong assumption of zero conditional mean, unbiased. If the two sets of variables are correlated, then there is an endogeneity problem that causes this inference to break down. We can see the first equation, which is the true economic relation, where W is an observable explanatory variable and gamma its coefficient. The estimate population regression becomes then the second equation, where V is the composite error term. If the omitted variable W is correlated with any explanatory variables, then the composite error term V is correlated with the explanatory variables. The consequences is, in the cases that the OLS estimation of the second equation will typically produce inconsistent estimates of all the elements of beta. The second source of endogeneity is the simultaneity, which occurs when the causal link between the explained variable and one or more of the explanatory variables can be defined. The last sources of endogeneity is the measurement error, which occurs when there is discrepancy between the unobservable variables and the proxies used to incorporate them in the model, either when the proxy is for the dependent variable or on an independent one. The third source is the measurement errors. The statistical implications of measurement error in the dependent variable are similar to those of the omitted variable. If the measurement error is uncorrelated with the explanatory variables, then OLS estimation produces consistent estimates. If correlated, then OLS estimates are inconsistent. If one or more than one independent variable is measured with error, then the OLS produces inconsistent estimates of all of the betas, even when the measurement error is uncorrelated with the other explanatory variables. There are a number of econometric techniques aimed at addressing endogeneity problems. We can classify them into two categories. The first category includes techniques that rely on a clear source of exogenous variation for identifying the coefficient of interest, such as instrumental variables, difference in difference estimators, and regression discontinuity design. The second category includes techniques that rely more heavily on modeling assumptions, as opposed to the clear source of exogenous variation. For example, the Panett data methods, matching methods, and measurement error methods. I will discuss later on one technique of each category. So first of all, I will talk about instrumental variables, which is one way to address endogeneity concerns. It aims to find one or more instruments for the endogenous regressor, XK. A valid instrument satisfies two conditions. Firstly, the relevance conditions, which requires that the partial correlation between the instrument and the endogenous variable do not be zero. They must be fully correlated. The second condition is the exclusion restriction, which requires that all instruments must be uncorrelated with the error term u. In conjunction with the relevant condition, the exclusion restriction implies that the only role that the instrument Z plays in influencing the outcome Y is through its effect on the endogenous variable xk. Any variable satisfying both conditions is a valid instrument. There is no restriction on the number of instruments. However, we must have at least as many instruments as endogenous regressor for the coefficients to be identified. The most common approach to use instrument is the two-stage least square, where the values of the endogenous variable are predicted by regressing them on all the exogenous variable and the instruments. Then the predicted values of the endogenous variable replace its original values in the regression of the explained variable. We can say that the endogenous regressor xk has two parts. The part that is uncorrelated with the error, called the good variation, and the part that is correlated with the error, called the bad variation. The basic idea behind the IV regression is to isolate the good variation and disregard the bad variation. Moreover, instruments can be from different natures, physical, biological, or institutional, and so on. And the good ones are those who affect the outcome variable only through the endogenous variable. That's why it's important to know the source of endogeneity and subjects at stake to justify the choice of an instrument. Falsification tests can also be useful to justify the choice of an instrument. It's also important to avoid weak instruments. For example, ones that are weakly correlated with the endogenous regressor, because that can lead to coefficient bias and distort inference. Lagged instrument can also be used. I will take as example CEO succession in family firms. So whether replacing an outgoing CEO with a family member hurts firm performance or not. And I will discuss about a valid instrument. In this example, performance is the dependent variable, Y, and family CEO succession is the endogenous explanatory variable, xk. The characteristic of the family and firm that cause it to choose a family CEO or not may also cause the change in performance. In other words, it is possible that an omitted variable causes both Y and xk, thereby leading to a correlation between xk and U. Family characteristics such as size and marital history are possible candidates because they are highly correlated with the decision to appoint a family CEO. However, if family characteristics are in part an outcome of CEO incentive, they may not be exogenous. That they may be correlated with firm performance. The instrument Z chosen is the gender of the firstborn child of a departing CEO. This type of biological event is unlikely to affect the firm performance. Endogeneity problem faced when the parameters used are panel data. This is why we use the panel data methods, because in panel data the error term can be decomposed in two parts, both related to the individual, but one of them does not vary with the time dimension. In this part, if this part is correlated with the covariate, then we are in presence of a fixed effect and inevitably endogeneity. To eliminate the fixed effect, one can decompose the error term and include individual-specific intercepts in the regression or differentiate the regression on the time. Thank you for listening.